All right, we're going to go ahead and get started. Again, in 3.5, we are looking at function notation, and really what we're going to do today is nothing new. What we're going to do today, you guys have done before. We're just going to be presented in the information in a new way that you will need to understand. So, equations that represent functions are often written in function notation. In your past, so your middle school life and even the beginning of this year, when you guys saw equations, you saw equations that look something like this: y equals 4x minus 1. Rewritten in function notation, it just looks like this. So all we've done here when we're writing this in function notation is we've replaced this y variable with this function notation. But those two things mean the same thing. So moving forward throughout like the rest of your high school and whatever, sometimes, yes, you may still see our variable y, but other times you'll see functions represented with this function notation with this f of x. Understand that this still, again, they mean the same thing. So this just means y, okay? This notation is read as f of x. So when you see something like that, it's read as f of x. F is not the only letter that could be used. It's the most common, but we could use g of x or h of x or m of x, whatever. It's just letters basically to name different functions. I'm going to name this linear function x or f, and then maybe I'll name this quadratic function h, so we'll know which one we're talking about. Are we talking about the linear or the quadratic based on, am I talking about function f or function h? So it's basically just used to name different functions. The x, as always, is going to be the domain of our function, right? X values are domain. And this f of x, which again is the same thing as y, means that f of x is just giving us the y value, which is our range value. Okay? So what we're going to look at today is how do we evaluate functions using this function notation. So function notation is especially useful for finding a value in the range that corresponds to a certain domain. So you're going to be given a domain or given an x value, and you're going to find what is the y value or what's the range when x is whatever it is. So here's our example. If f of x equals 4x minus 1, find f of negative 7. So what you need to understand, here's the big picture that you need to get today, is that when you see this notation, whatever value's on the inside of the parentheses, that's your x value. That's what they want you to evaluate the function at. So this x is equal to negative 7. So all this notation is asking you is what's the y value when the x value is negative 7? So if my function is that 4x minus 1, and I'm evaluating it for x is equal to negative 7, all I have to do is take this value of negative 7 and plug it in for x. So you've done this before. You have plugged in numbers for a letter and solved equations. So that's why I'm saying what we're doing today is not new. You just have to understand that that's what this notation is asking you to do. Plug in negative 7 for x, and then find the output value, find the y value. So this would be 4 times negative 7 minus the 1. And again, once we've plugged that in, now you're just using order of operations, which means we need to do this multiplication first. So 4 times negative 7 is going to be, if you don't know, you have a calculator. We're not just passively waiting for someone to do the math for us. Negative 28, very good. And then I'm going to bring down the minus 1. So now I can do the subtraction. Negative 28 minus 1 is negative 29. So f of x is equal to negative 29. And remember, f of x just means y. So when x was negative 7, the y value is negative 29. All right? We have got a handful more that we are going to practice. If you feel like you are getting it and you want to work ahead, do that. And then that way you can always go back and check, like, did you get it right? Whatever you do, don't fall behind. Don't just sit there and wait for someone to give you the answer. Be active in this process, okay? So, the first one, we're going to evaluate each of these functions for the given value. Number 1, we have f of x is equal to 3x minus 8 for f of 5. So again, understanding that notation, they're telling you this is the x value. So we're going to take that x value of 5 and plug it in wherever x is in the function. So to find the y value, I am going to do 3 times 5 minus 8. And then very similar to our last linear example, we're going to do that multiplication first. So 3 times 5 is 15, and then 15 minus 8 means that f of x is equal to 7. Very good. All right, number 2. We've got h of x is equal to 1/5 x squared, and we are evaluating that for h of 15. So now we have a quadratic, but again, same thing. They're giving me the value for x, so all I have to do is take this x value of 15 and plug it in for x. So I am going to evaluate this 1/5 times 15 squared, because it's 1/5 times x squared, so it's 1/5 times 15 squared. Now, order of operations. What do I have to do first? The exponent. So you have to square the 15 first. Everybody know how to do that on your calculator? This little button right here that says x squared, this allows you to square something. So you would do 15 and then hit that squared button. What is 15 squared? 225. Very good. So now I have 1/5 times the 225. So now I just got my last step. All I have to do is multiply 1/5 times 225. And we all know how to make a fraction in our calculator. So what do we get? If you don't have a calculator, you need to go get one. Very good, 45. Thank you, Marley. Good job. So all we're doing is plugging in a number for x and using order of operations. That's it. And the number that you're plugging in for x is whatever's in the little parentheses. Number 3, another quadratic. F of x is equal to negative 2 times x squared minus 3x plus 1, and we're solving this for f of 2. So we're understanding 2 is the value that they want us to plug in for x. This equation has x in 2 spots. Cool. Plug it in both of those. Wherever x is in the equation, plug it in. Okay? So this is going to be negative 2 times 2 squared minus 3 times 2, and then bring down that plus 1. So wherever x is in our equation, I'm just plugging in that number, and then I'm using order of operations. So just like the last one, I need to do this exponent first. 2 squared is 4. So this is negative 2 times 4. We can do this multiplication if you guys want right now. This negative 3 times 2. Again, Did you hear me say this is a negative 3 times 2? We need to get in the habit of looking what's in front of that number, because if it's a minus sign, it's a negative. If there's a plus sign, it's a positive. So when we do this multiplication, we need to do negative 3 times 2. What's negative 3 times 2? Very good. So minus 6 plus 1. Since it's negative 6, I put a minus sign. If it was a positive, I would have put a plus. Okay? Now all I got to do, I've got some more multiplication that I need to do here. The negative 2 times 4 is... negative 8. So I have negative 8, and then the minus 6 and the plus 1. Now I can just go ahead and put this in my calculator from left to right. Negative 8 minus 6 plus 1. Negative 8 minus 6 plus 1. Negative 13. Very good. Just like that, you've evaluated that function. All done? Awesome. All right, 2 more. Number 4, we've got an absolute value function, but it doesn't matter what kind of function it is. We're still doing the same thing. We're going to plug it in, and we're going to solve it. So we've got g of x is equal to the absolute value of 1 minus 7x, and we're solving this for g of negative 3. So the number inside of these parentheses, that's our x. So we're going to plug that negative 3 in right there. So we've got the absolute value of 1 minus 7 times the negative 3. Make sure we don't forget those absolute value bars. We are going to simplify inside of the absolute value bars first. So we're going to do this multiplication. Remember, when you do this multiplication, this is a negative 7 times negative 3. Positive 21. So now I have the absolute value of 1 plus 21. Since it was positive, we're going to make it a plus. Now, inside of the bars, let's go ahead and do this addition. 1 plus 21 is 22. So now I just have the absolute value of 22. Remember, absolute value means how far is it away from 0? Right? Absolute value represents a distance. Distance is always positive. The absolute value of 22 is just what? How far is 22 away from 0? 22. So g of x is equal to 22. As a reminder, because you guys are going to see one like this on your formative, if I had the absolute value of negative 22, still, absolute value is how far away it is from 0. So I don't care that it's to the left. Negative 22 is how far away from 0. How many spaces? 22 spaces. So this would still equal a positive 22. So the absolute value of something is always going to be positive. Keep that in mind. Okay? So that's just a little extra review there. Last one, that's a pretty straightforward question. Number 5, f of x is equal to 3 times 2 to the x power. So now we have an exponential function, and we're evaluating this for f of 5. So still, this just means that this 5 is my x, and my x is the exponent, and that's okay. I'm still just plugging it in. So when I plug this in, this would be 3 times 2 to the 5th power. Just like with our quadratics, we need to do the exponent first. Do you guys know how to make any exponent you want? This button right here, that y to the x right below the off, this button will allow you to make any exponent that you need. So to do 2 to the 5th power, you would hit 2, and then hit the exponent key, and then hit 5 and equals. And that would give you 2 to the 5th power. So 2, and then this y to the x, and then 5, and that equals. So 2 to the 5th power is what? 32. Great job, everybody. So now we just have 3 times the 32, which means the y value, or the f of x, is equal to 96. Great job. So evaluating functions, they're going to give you a number for x. You're going to plug that number in, and you're going to just make sure you do the correct order of operations to find the y, or f of x, because f of x just means y. Okay? All right, last one. Let's get a little story problem here. Anthropologists use the length of a certain bone, or of certain bones, of human skeleton to estimate the height of a living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, so look, they're defining what my x is. X represents the length of the femur. The function h of x is equal to 61.41 plus 2.32x can be used. Part A just says find h of 46. So they gave us a scenario, but essentially part A is exactly what we did on the last 5, because they gave us a function and they're asking us to find h of 46. So by giving us this 46, they're giving us a value for x, and we're going to take this 46 and we're going to plug it in for the function that they gave us in the little story problem. So we're going to plug it in right there. So this would be 61.41 plus 2.32 times the 46. And then, again, order of operations is always important, so we need to make sure that we do this multiplication first. So this would be 61.41 plus what? What do we get when we do 2.32 times 46? 0.7 what? 72. And now that you've done that multiplication, now you can go ahead and do the addition. So 106.72 plus the 61.41 means that h of x equals 168.13. Okay, very good. Now, part B just says interpret the answer to part A. So all you have to do here, none of it is really like think too hard. All you got to do is read the problem again. What are the two things we're comparing here? I underlined one of them, which is what? The femur length. That was our x. And we're using that to find what? What were these anthropologists using that for? To find the height of that female, right? So if x was 46, which is the length of the femur, and what we found was 168.13, what did we find? What were the two things we're comparing? We said we're comparing femur length with what? The height of the female. So what does this answer mean? Yeah, which is what? Be specific. Huh? Okay, so specifically 168.13 centimeters, right? We know the exact height of that female, or we can estimate it, right? So I don't want to really put the estimated part. We'll just whatever. The female is 168.13 centimeters tall. So if that female has a 46 centimeter femur, then their height is going to be 168.13 centimeters. That's what we were comparing. Femur length and how tall they were. Okay? So again, part A is very simple because it's the same thing we did in the beginning. And then part B, you're just rereading and saying, what am I comparing? What are the two things? What is my X? What is my Y? Okay, that's it. All right.